The next best practice tip I want to give to you is to write good code yourself. By that I mean decent variable naming, method names that effectively describe what the method does, property names that make sense for the class they're part of, and it's probably also a good idea to use a few of the solid principles, like the single responsibility principle. We all know this, right? But let's be honest, a lot of us will still sometimes name our variables var1 or var2, or maybe write a method with the name SOMEMethod because you haven't figured out how to come up with a better name yet. I know I'm still guilty of these things from time to time, but it's not a good idea. Well, in fact, writing code like that was never a good idea, but when you're working with Copilot, it's definitely a very good idea to stop doing this, because Copilot learns from your code as well. It uses it as context, so your code will likely be part of the prompt. Let's have a look at that with an example. So in the previous clip, we asked Copilot to generate an extension method on type person that calculated the age from the date of birth. If you look at line 7 here, you see that we named that date of birth property birth date. Copilot was smart enough to figure out that that would be the date of birth. But let's see what happens if we change this. Instead of having one property named birth date, I'm going to add two properties of type date time offset, can potentially hold null as value, and I'll name one some property and I'll name the other one another property. Not exactly good naming. Now let's see what happens if we ask the same question as before, in line, why not, in the next demo file. So create an extension method on type person that calculates the age from the date of birth. We get a few suggestions, but what you see in all of these is that Copilot simply had to guess. It simply took the property named SOMEProperty and figured, well, I'm not sure which one is the date of birth here. Let's just take the first property I encounter. That's of course not a good thing. Let's see what happens if I change one of the property names to birth date. So let me change another property to birth date. Let's see what happens now. And there we go. This time Copilot figured out that it's probably the property named birth date that would contain the date of birth. Let's try something else. I'm going to open the OrderLine class here. Say I want to write a method that calculates the average order line price. The OrderLine tab is open here. I can close the person tab, I don't need that anymore. So in next demo, I'm simply going to start typing. One of the first suggestions I get here is indeed a method that tries to calculate the average of two inputted integers. But that's not really what I want, right? I want to write a method that calculates the average order line price. So if I'm a bit more specific about that, it's already picking up the order line here, as you can see. Let's be more specific, calculate average order line price. And what you see here now is that due to the fact that I used better naming, that the suggestions also become better. I'm naming my method calculate average order line price, and what you see is that Copilot suggests that the parameter that's inputted is an array of order lines, and indeed in the body the average order line price is calculated. So that's something we'd want to accept. So by correctly naming methods and variable names, you also provide Copilot with better context, leading to better results. Final best practice is to try again and experiment. Prompting and prompt engineering is not an exact science. The same prompt will not necessarily always generate the same results. So don't be afraid to adjust your prompt and experiment. You don't need to use all the best practice techniques together. Use those that you feel the most comfortable with, and the ones that yield the results that you want. But know that you will probably get better results by combining different techniques. especially the ones that provide additional context to Copilot, and the step-by-step approach are, in my opinion, very helpful. Also, not everyone uses AI in the same way. I've seen people trying to write the perfect prompts that fully generate all the code they need, as correct as possible. But maybe by doing that, they're spending so much time on maximizing the correctness of the prompt and thus outcome that the end result is wasted time, because they could have just coded a bit themselves. If your main goal is to increase your productivity, spending too much time on creating the perfect prompt may not be the best approach. The other side of the coin is not using Copilot to its fullest, by which I mean writing a simple prompt that results in code that more or less is what you need and leaving it at that. In other words, using Copilot as nothing more than a starting point, assuming it won't be able to generate something better anyway. That's the mistake I made in the beginning. And while using Copilot like that is still helpful, you'd not be unlocking the true potential of it. Often Copilot can help more than you think, so don't underestimate it. And with that, it's time for the section summary. In this section, we dived into prompts and prompt engineering. A prompt can be seen as the combination of everything that's fed to Copilot's GPT. It's the sentences in natural language that you write, combined with code and other contextual information. Prompt engineering, then, is the process of writing prompts in a way that will make Copilot generate better or more specific suggestions. Prompt creation starts with algorithms that run locally in your IDE, selecting relevant code snippets from comments from your current open file and other sources. The prompt library then takes all these potential sources of information, prioritizes them, and creates the prompt that is sent to the local contextual filter model. This is a process that is constantly happening in the background. The contextual filter model decides if the prompt should be sent to the cloud, where the large language model lives. Once the prompt is sent, the rest happens in the cloud. Copilot's generative pre-trained transformer, or GPT, takes the prompt and tries to come up with suggestions. Those are eventually returned to Visual Studio, where they are potentially shown. Best practices for writing prompts and thus getting better suggestions are setting the stage, providing examples, being specific, going step by step, providing context, and writing good code yourself. So, you know what AI and Copilot are, what a prompt is, and you know a thing or two about prompt engineering. Now it's time to use Copilot in your day-to-day life as a developer. That's what this section is all about. Imagine that this is your first day in a new team. They've been working on a project, but you don't know it yet. The reason you're added is because the project is running overtime, the deadline is looming, the client isn't very happy anymore, and there's still a lot of features that have to be developed. You're a great developer, that's why the team wanted you to join, but even then, adding a feature to a codebase you don't know, with a deadline that's approaching fast, is not ideal. As an experienced developer, you know that the task at hand won't be easy. Luckily, you don't have to develop the feature alone. You've got Copilot to help you. We'll first have a look at how Copilot can help you understand the existing codebase you've been catapulted in. Then, step by step, you will learn the different ways Copilot can help you develop the feature, from suggesting code, over documenting the codebase, to helping during debugging and figuring out exceptions. Let's dive in.